So now we have to understand what this nexts method does. So nexts takes a set of paths and returns the set of all paths that are one longer, but not visiting nodes that we've already visited. So I'll say that again. So given a set of paths, nexts will return all the paths that are one longer than the ones in the path so far, but not visiting places that we've already visited, because we don't want to do that. And the reason we've got this end here as a parameter, because if we discover that end is in one of these paths that are one longer, that means we've finished, because we found a shortest path to end. So let's look at how nexts works. Well, in fact, we've got two nexts methods. We're using overloading here. One that takes a whole set of paths and finds all the ones that are one longer, as I just explained. But in order to do that, we need a method which takes a single path and finds the set of paths that are one longer. So here we've got a nexts method which takes a single path and returns the set of all paths that are one longer. So how does that work? Well, so here's our path that we're trying to find all the paths that are one longer than that one in our graph. So we take the last element of the path. Here we do that. So we must know here that the path isn't empty. We take the last element of the path, and we set this thing here, this set nays, to all the neighbours of the last thing. So those are all the places that we can reach in one step from the last point in this path. So that's the next. These are the points that will make the path one node longer. So now for all those neighbours, this neighbours set here, we can check where the neighbours contained end. If it does contain end, it means we found a shortest path. So what we're going to do is we're going to set done to true, which means the other loop will finish, and we add this path to we add the path with the original path with end stuck on the end to our shortest paths global variable. Now, if none of those neighbours is end, what we want to do is for each of the neighbours, if we haven't already visited the neighbour, then we want to add that neighbour to the path and add the resulting path to our set. And also all the neighbours we add to the ones that have already been visited at that step. So there are two possibilities. Either we find end in the next step, in which case we add end to the path that we've got, and we add the result to the shortest paths, and we set done to true, which will get us out of the loop down here. If none of them is end, then for all the ones that we haven't visited, we add those for all the neighbours that we haven't already come across, we add those to the path and add the result to our set k. And at the end of that, we return k. So k will be the paths that are one longer than the one we had before, starting from a single path. Now we have to do that not just for a one path, but for a whole set of paths. So what do we do here? For each path in our set of paths, we add all the nexts. Now, it's possible that that's not going to add any new things. Now if that's the case, it means that we've already visited everything, so we've finished doing that, so in which case if k is empty, we set done to true, and that will return us from this thing. So basically we're simply applying this next function to all the paths in this set of paths.